Okay, we're ready to now go on to our next session, and I'm going to introduce my colleague here, Professor Ravi Sarathi, who is a professor of international business and strategy in the Damore McKim School of Business. And the topic is completely from groundwater, we're going to outer space now, innovations in space exploration by the Indian Space Research Organization. And I'll let Ravi take it from here. Thank you, Ravi.
Thank you, Ravi. Yeah. As you might gather, Ravi is a pretty common name, and I'm proud to share it with my colleague, Professor Ramamurthy. Yes, as Ravi just mentioned, water is a daily pressing need and a very important need for a country of over 1.3 billion people. And space is much more of a long-term issue. And it's something that might be important not just in the next decade, but for the next 100 years or even much longer. As we know, people like Elon Musk want to have the ability to go off into Mars in case, I suppose, something happens here and they wish to escape. Now, that's an escape hatch for very few people. But space has many, many possibilities. My speaker today is Dr. Umamaheswaran. He's a scientist. He's a very distinguished scientist with a PhD in electronics and communication. He served at an outfit called ISRO, which is the Indian Space Research Organization. He worked there for almost 35 years, and currently he's the director of the Human Space Flight Center in Bangalore. And he has received many awards, including Outstanding Achievement Award from ISRO, and his career at ISRO culminated being the scientific secretary, one of the highest scientific positions at ISRO. So it's my great pleasure and honor to welcome Dr. Umamaheswaran.
Okay. Thank you, Professor Ravi Sarathi. And other colleagues, Professor Krish Nangagadda and Sandrine Mallet, and the other organizers, as well as the distinguished guests who are already assembled there, and also across the world, as I believe. Very good morning, very good afternoon, and very good evening to all of you, depending on where you are. So I have been allotted, as I understand, around 15 minutes. For the topic, basically, we are talking about innovations in Indian space program. It's a very interesting topic, I thought. So, if you really ask me, everything about Indian space program, according to me, is kind of innovative ventures only. It is not only, I would say, innovation in technology. It is innovations in science, it is innovation in the strategy, innovation in costing, and I would say even innovation in thinking process. In fact, I would say it has become a kind of a way of life for we people in ISRO, which I am very proud of. The entire gamut of the Indian space program, if you ask me, is enshrined, I would say, in the India's fundamental culture, and that has been successfully translated, I must say, to what we call ISRO culture. Basically, I would say that the entire responsibility of this belongs to, beginning with our founder, I will say the father of Indian space program, Dr. Vikram Sarabhai, a great visionary, and this particular culture or this particular aspect or this particular kind of mechanism has been successfully transferred to the next generation till now, and I think that is the biggest boon or the biggest advantage that we in ISRO has. Basically, the leaders that we had, starting from Dr. Vikram Sarabhai to the present secretary and chairman, Sri Somnath. It all began, as you know, in 1963 with the launch of the first Nike Apache sounding rocket. In fact, this mission of the sounding rocket, Nike Apache itself, I will call as an innovation, because this rocket was obtained from U.S. The payload, which is nothing but sodium vapor, was obtained from In fact, the erstwhile CNS at that time, and Professor Jacques Blamont himself brought that sodium vapor lamp to us, sodium vapor to that payload to India, because he was a great friend of Dr. Vikram Sarabhai. So from the beginning itself, ISRO's approach has been not only cooperation with international agencies, but also a great collaboration with the industry. From 60s onwards, we have been treating industries not as a kind of vendors, they are partners. So the technology development will go along with the development of these industries by transferring these technologies to them so that they can develop the products, and it is a mutual win-win situation for them as well as for us. So this has been one strategy that has been evolved from the 60s onwards. So this first launch of choosing the sounding rocket station from a remote place, I would say, on the southernmost part of India, in a sleepy village called Tumba in Kerala, state of Kerala, itself is very innovative, I would say, because the location was chosen because of the proximity to the magnetic equator. And the sounding rockets, if you launch, as you know, from magnetic equator, the upper atmosphere, the data that you can collect, the kind of phenomena that is happening in the upper atmosphere can be easily understood, the data can be collected. So that is the importance of magnetic equator. And the site was chosen. There was a group of fishermen, a family of fishermen residing there. And Dr. Vikram Sarabhai requested the Archbishop of Kerala, Trivandrum, at that time, and he requested whether they can be moved. And the Archbishop himself, a great visionary, convinced those fishermen and asked them to move out. They will be relocated, rehabilitated accordingly, saying that this is a great kind of research that is going to happen in this place, which is going to benefit millions of Indian people in future. And he convinced them, and they moved out. And the first experiment on Indian space program started in the church building. And what more innovation you need than this? I can quote that. So from that very humble beginning, we have translated into what we are now. We are talking about going to Gaganyaan human space program. We are talking about huge satellites as well as small satellites, depending on the dynamics of the market that is happening. We have traversed to the last 60 years. But the beginning was exciting as well as tough. We didn't have our own launch vehicle, so the design aspects or design efforts to make our own launch vehicle started in the 60s itself. And there again, whatever we do, the concentration or the objective of whatever we do was especially with respect to what this attempt or what this kind of effort can get translated into the benefit of the society. Dr. Vikram Sarabhai used to tell that we should be second to none in the committee of the world or the committee of the spacefaring nations in converting, translating the technology that you get from space, the data that you get from space to the benefit of common man. And this has been exactly what ISRO has been following till now and for future also. So this is the kind of approach that we always take, and the cost part is always in the back of our mind. You know that even now the percentage that the budget is allotted for space is less than 2% of the entire budgeted amount for the country. So that with that frugal amount only, we need to carry out all these innovative as well as optimal activities, culminating in the benefit of the society. So we started making our own launch vehicles. As you know, we started with SLV. Our late Honorable President, Dr. Abdul Kalam, was the first project director of that. And from SLV, we moved immediately to what we call augmented satellite launch vehicle. This was also a very innovative idea because we have, at that time itself, we were on the drawing board for our next generation of rocket, what we call polar satellite launch vehicle. If ASLV was 150 kg payload capability, we were aiming for 1,000 and above, 1,000 kg and above payloads for the requirement of remote sensing in the launch vehicle of PSLV. It was a quantum jump at that time itself. So what we did in augmented satellite launch vehicle program was to try out the major technologies, the key technologies that is required in order to achieve the mission of polar satellite launch vehicle. For example, something like closed loop guidance system, the different strap-on mechanisms, different separation mechanism, all these technologies were tried out in this augmented satellite launch vehicle and which successfully culminated in the first mission of polar satellite launch vehicle in 1993. And now polar satellite launch vehicle is also a beautiful launch vehicle, as you might have heard by this time. It is one of the most reliable launch vehicles available in this world, and there is a lot of demand as far as the commercial aspect for the launching on PSLV. You know that in 2017 we launched 104 satellites in one go. 104 satellites in one go, which was a record. Very recently SpaceX broke it. So PSLV is a very versatile rocket. You can take payloads up to 2.3 tons to 2.5 tons to low Earth orbit for remote sensing purposes. You can take it to GTO orbit also. Of course, the payload will be of the order of 1,300 kg to 1,400 kg, and for communication purposes. And that is also the launch vehicle which sent the Chandrayaan-1 as well as the our Mars orbital mission, which I will come to that a little bit later. And but PSLV was not adequate for us because it didn't have the real capacity to launch a huge or a bigger communication satellite, which is also a need of the hour. And we needed communication satellites at least of the 2-ton category, for which PSLV was not capable of. So we parallelly ventured into the next generation of rockets, which we call geostationary satellite launch vehicle (GSLV). Initially, what was called Mark II, and the Mark II was designed for a capability of around 2 ton to 2.3 ton in GTO. And for that, as you know, since GTO is for geostationary orbit is 36,500 kilometers, the requirement of a cryo stage was essential, and the acquiring of cryo technology was absolutely essential. And initially, we wanted to collaborate with Russia with respect to the acquiring the cryo engine technology, but as you know, the geopolitical situation did not allow us to get that. Of course, Russia helped us by giving assembled stage, and the initial PSLV missions were with the bought out Russian cryo stage as such. But when we realized that we are not going to get the technology, we started developing the technology on our own, and which culminated in the first successful indigenously developed cryo engine in 2014, which is GSLV mission, which was a great success. And I would say that is one of the biggest achievements that ISRO has ever done, because acquiring the cryo technology is not a small thing. And all the spacefaring nations across the world will not respect us if we don't have that technology. And we could achieve it on our own from scratch, and that was the biggest achievement I would say we have. But parallelly, the satellite development also was going on. We had our own remote sensing satellites. Earlier, we developed our own remote sensing satellites, but we didn't have the launch vehicle in the earlier 70s. So we went to Russia for launching remote sensing satellites, and we went to Ariane for sending the communication satellites. Subsequently, we had our own launch port. We built our own launch port in Sriharikota, and which has got two launch pads now. And from there, we started launching our own communication satellites, as well as which are called DSAT series, as well as remote sensing satellites, which we call Carto series, OceanSat, like that. And let me also tell you that subsequent to in later 2010 and beyond, we have developed our own synthetic aperture radar capabilities, as well as high throughput satellites. We are now attempting for 100 Gbps capability, and also hyperspectral imaging technology. We have already launched one satellite with hyperspectral imaging. So all these things again are focused on how the data can be beneficial to the society. As you know, we have the entire remote sensing data that is available with our satellite constellation has been totally translated to the different government as well as other agencies, and the benefit I need not tell you. benefit that is going to the society. I cannot specifically mention to you. For example, just now, the earlier speaker was talking about the water resource and related aspects. It was a great achievement, I must say. And the contribution that our remote sensing has given for the detection of water, its depletion, etc., you can just understand. And also the Jal Shakti Abhiyan, the contribution, ISRO is really contributing to such efforts. So most of the, I would say more than 80% of the major governmental as well as non-governmental efforts that is going on in relation to the improvement of the livelihood of our society, space is involved. And more than 150 departments are involved with us in various application areas. And I can also tell you that for one specific example, the data that you get or the application that we have given to the fishermen, especially in the coast of Tamil Nadu as well as in Gujarat. Now you can see that their total lifestyle has changed because they know exactly where the shoal fish is available, go there, catch the fish and come back, and that has transformed because now the cost is reduced, the cost of fuel is reduced, and the quantity of the catch is quite substantial, and that has lifted their I would say the economy totally. So this is the kind of benefit that these people are getting. And you take the case of weather forecasting. Now the kind of depth or kind of disaster that is happening due to cyclones, especially in the eastern part of India. Earlier, at least 15 to 20 years back, then the number of deaths reported were of the order of, let us say, 5,000 kind of scenario. Now you see, you can count in fingers that 2, 3, 4, and that too mostly because some of the people don't heed to the warnings given to them, and they still continue to be there. That is a kind of I would say intangible benefits that you get from space. Okay. Now,
Dr. Umamaheswaran, if I might interrupt for a second, perhaps another 2 or 3 minutes of talk, and then we can move to Q&A, perhaps.
Pardon, sir?
Maybe 2 or 3 minutes more, and then we can move to Q&A.
Yeah, I will just touch upon 2, 3 aspects now. One is with respect to the scientific missions that we have conducted. For example, Chandrayaan-1, we did a Mars orbiter mission, Astrosat, Chandrayaan-2, of course. All these were very, very innovative, cost-effective efforts I wanted to mention here. And Chandrayaan-1, we was successful in detecting the presence of water in the moon. And I don't have to mention about Mars orbiter mission. The first, we are the first country to succeed in entering into Mars orbit in the first attempt itself, and we are the first country to totally image the entire sphere of Mars, I would say. And then Astrosat also is very unique because a wide spectrum of the different bandwidths we could get from a single satellite or single Earth observatory, that is space observatory, and that is one of the beauties, or that is one of the most widely talked about innovative effort of Astrosat. And you know that Astrosat could successfully detect the coronal explosion of Proxima Centauri, and it was also helping solving a puzzle of a source simultaneously bright in IR as well as UV. This is very unique. And Chandrayaan-2, very recently, there are 8 payloads in Chandrayaan-2. It has mapped the surface composition of sodium in the moon for the first time. So these are all some of the very innovative programs that we have carried out. We have a few programs in store for us, like we have Exposat, we have Aditya L1, we are going to the Lagrange 1 point, we have Venus mission, and we in collaboration with JAXA, we are going to have a lunar polar exploration, we have Exposats. And coming to the launch vehicle as well as satellite development, also as I told earlier, new developments we are attempting now. One is new gen launch vehicle, as we call it, which will be cost efficient, which will be reusable, and it is basically intended for a higher payload of around 10 ton to GTO. At the same time, cost effective, using semi-cryogenic booster and basically it's a modular kind of construction. So this is one, it's like that we are on the constant path of evolution and innovation to satisfy the requirements of our society and to make their life more comfortable and in a much better way of life. So this is what I would like to tell you. I think I will stop here now, and maybe further aspects we can discuss as part of the question hour session. Thank you very much.
Dr. Umamaheswaran, that was a very, very succinct and broad, at the same time, introduction to the achievements of the Indian space industry. Let me start off by asking you a question. You mentioned that you have a relatively frugal budget, and at the same time, you want to try to use it optimally and to provide great benefits for society immediately rather than in the long term. Do you get any pushback from politicians and from the government in terms of the value of space research, particularly given other pressing problems that perhaps the budget also needs to fund? And how do you handle those kinds of pressures?
Thank you for that question. In fact, I'm very proud and happy to say that I would say lawmakers, I would call them, are extremely aware of the potentiality of the space application through the space data. In fact, I can tell you, in 2017, Honorable Prime Minister Modi himself took the initiative to arrange a 3-day session with around more than 150 state and government departments, and they were asked to speak about what space can do to them. And based on those discussions, which was a 3-day workshop, some more than 200 programs were initiated in various platforms, I would say. Which, for example, I can tell you one small example of manning an unmanned level cross for a railway system. This is one minor example that I can give you. So like that, all these projects, I would say from 2017 onwards, whatever we have envisaged in 2021 we have completed, and more aspects are coming on now. So the kind of pressure, as you rightly told, for us to meet the demands itself is becoming a real challenge to us. But we are trying to rise to the occasion and try to meet the needs of the growing needs of the different parts of the society.
Thank you. Are there any questions from the audience? Yes.
Thank you, Dr. Umamaheswaran, for explaining the successful journey that Indian Space Research Organization has achieved so far. So my question to you is, recently I heard, so there is the private partnership with ISRO. So ISRO is promoting the private company to use their facility and services to launch the satellite at low cost, like similar to the SpaceX is doing here using the NASA facility. So I want to know, like, what work has been going to promote, like attract the more private companies to use the ISRO infrastructure for launching the satellite at low cost?
Thank you very much for asking that question. Government of India has announced reforms in the space sector also in 2021 with respect to enabling the private sector to carry out their space activities in India. See, till now, all the space activities, whatever that is happening, has been spearheaded by Indian Space Research Organization under the Department of Space, which is a pure government, semi-government organization. Now, government felt that it is the right time now to change the perspective, wherein you need to introduce a mechanism wherein the private players, I would call them non-governmental entities, not only private, it is academia, it is startups, and the whole host of stakeholders are involved. And they should be enabled, they should be handheld, and they should be promoted to carry out, invest as well as carry out their own space activities for the benefit of, again, it's a win-win situation for the society. So a mechanism called InSpace has been put now, and InSpace is not only a hand-holding, a promoting agency, but it is also a kind of a regulatory body. Now the issue is, India didn't have a space policy, defined a space policy as of now, and so now a space policy is defined, and a Space Act, which is very soon it will be put into Parliament, and it will become as a law. So once this comes through, the infrastructure or the requirement are well defined, so that it will enable, or it will help the private sectors to understand what is the kind of boundary with which they need to operate, and what are all the regulatory requirements they have to meet to carry out their space activities. At the same time, we are extending whatever facilities which ISRO has and which are not available in the country, for which if the private players have to invest, it will be huge amount of investment. So that we are extending the facilities to the private players also, who are coming to do their space activities. For example, now there are two young entrepreneur teams, startups, I would say, who are making attempts to make small satellite launch missions. And very soon, in the next one, we are going to have two launches from the startups. And we are extending our facility for testing their systems and hand-holding them also. So this is going on. It has started now. More than 100 private players, which includes startups as well as big players, have come up now for doing their space activities. For your information, Polar Satellite Launch Vehicle, which is a workhorse of India and ISRO, I would say, has been given to now a kind of consortium of the industry, and they are going to make PSLV from scratch now onwards. So it is handed over to industry, and they will start making the Polar Satellite Launch Vehicles in numbers depending on the demand. So this is a kind of transformation with respect to the partnership and the entry of private players to carry out their own space activities. ISRO will continue to do the activities, including research as well as strategic requirements, and also the potential needs of the society. That we will continue to do. So this is the scenario.
I think quite a few of my questions have been answered so far, actually, but I'm going to contextualize it in terms of my own experience and exposure, which will add to what you have been articulating so far. My experience was very limited. I was interning in the summer of 1974 on a project called SITE, Satellite Instructional Television Experiment, out of the business school summer project at the Professor Dhawan's office. And it's a classic example of an experiment which was thought leadership, and it involved satellite, when satellite was not even thought about for anything beyond military, instructional television, and television for being used for villages of India. I think Ravi talked about the confluence of public, technology, and information. I'm talking about 1974, 75. So my imagination was ignited by that project, even though I never stayed back in ISRO, but I thought I should mention that. And one of the key aspects that came through was the backflow of technology into the society in terms of building the technical capability within the country was phenomenal. Whether it is site experiment or subsequent launches, or even today you talked about how Agnikul and IIT Madras, which I'm very familiar with, they're trying to set up a launch vehicle, etc. The question for you is, with so much of infrastructure having been built, and Ravi's passionate topic of reverse innovation, how do you make this impact India, but impact global? Because I think we have a resource, from a thinking perspective and an infrastructure perspective, and a low-cost approach. How can we make it impactful for the rest of the society beyond India?
First of all, let me thank you for mentioning SITE. I think even before the rest of the world started thinking about tele-education and the application of through satellite, the SITE was conceived and executed successfully. So that is a classic example. Thank you for that. And as you rightly told, now the kind of activities that the private players are now coming into fore with respect to space programs One specific aspect which I'm very delighted is the kind of extraordinary kind of ideas that is being coming out from the next gen, which is very, very promising. So you mentioned about Agnikul, you mentioned about similar Skyroot is another example. There are many, many such people, and people who are making satellites also. They are bringing out innovative designs, and whenever you have an innovation in engineering as well as the technology or the science part of it, and they have a very conscious effort in reducing the cost also. So it jives very well with the approach that ISRO is always having with respect to the cost part. Now, basically the kind of approach that we need and which ISRO is always following also, I would say, to a very large extent, is basically that we minimize. The approach is always we try to be modular. We try to limit the number of tests that are required by ingeniously conceiving certain number of tests. And basically, as we know, India being the kind of social setup that we have, the employer or the cost of the worker is much 1/10 less than the rest of the world or spacefaring nations, and we try to have indigenous our own technologies. So this is a major aspect. So similarly, simple design, payloads will be less complicated, the way we achieve for Mars orbiter mission. It's a very, very, very simple payload, but the effect or the kind of application that we could get matched what the rest of the world needed. So this is the kind of approach we take, and I'm extremely happy that the youngsters or the new gen are also coming with much more innovative kind of processes, which includes cost reduction also, and their effort, I am sure, will make the more benefit to the society. Not only that, it will become more competitive in the international scenario, so that more people will now try to come here and do the job with us or with these private industries who are going to do the job for them. So that kind of potential I am really seeing now with these efforts. I hope I have answered what you asked. This is what I gathered from your question. If it is different, please tell me.
Thank you very much, Dr. Umamaheswaran.
Thank you very much. That was good.
That was a very fascinating talk about the Indian space industry. I think we could go on for much longer talking about some of the new missions and the cost advantages and the ability to work globally, particularly your work on the long-term sustainability questions surrounding space research and space travel. But we're running out of time, so I know it's late for you, well past 9, probably 10 p.m. in India. So thank you for taking the time to extend your day and give us such insights into the Space Center, ISRO, and your work with human spaceflight. I wish all of your colleagues and yourself the best in these efforts, and we hope to keep hearing great things from you. So thank you very much.
Thank you very much.